Hey y'all, so we're going to be moving into a new unit, reviewing radian measure. So this is a topic we've actually looked at briefly in the fall, earlier in the year. We're going to jump back into it, and it has a lot to do with trigonometry. It's going to lead us into something called the unit circle, which we do definitely need to learn a lot more about. So this is what this is. So this is reviewing that. So before we hit to the math part, just reviewing, like again, what is radian measure? It has a lot to do with degrees. But what's wrong with just using degrees? It's a way to measure kind of like an angle. The radian measure though basically relates more to like the circumference or like the length of the outer part of the circle, kind of like the perimeter of the circle is what the radian measures. Whereas, for example, here we have a circle. And if I draw an angle, let's say I draw it 30 degrees, right? I'm opening it about 30 degrees right there. Cool. That gives me a good idea of how far I'm opening it at, right? But what if I wanted to know what is the length of this segment right here? Basically, like what is the arc length is what I'm looking for. This arc length measure is called the radian. So this part that I just colored in right here, that's your radian measure, and that's why it's useful. So it's good to have both degree and a radian measure. The reason for that, there's a lot, but for example, let's say if a ball is rolling and I want to measure how far the ball has traveled. Now, I'm not going to say this ball traveled 30 degrees. That wouldn't really make sense. Like, how can I measure what 30 degrees of distance that a ball is rolling on the ground is, right? First off, 30 degrees for a bigger ball is going to be a different distance when a ball of when a smaller ball, same degree, rolls about on the ground. It's going to be different. So what we need to know is what is the length of this, and the radian is going to tell us that, because the radian is the stuff or the thing that measures the length of the circumference or the perimeter of the circle. So that's the why. Why do we just why do we need more than just degrees? We need something called the radian. Okay, so just as a preview, this is the unit circle. We're going to be talking a lot more about this unit circle later on. So this is just to take a look at that. Notice how there's degrees, and right by it we have the radian. So degrees, and then there's the corresponding radian, degrees, radian, and so forth, and it goes all around in a circle. This is the unit circle, and our goal is to learn how to use this. Okay, so yeah, that was just a preview, so don't worry if you got a little bit like overwhelmed looking at that unit circle. That's just a preview, but here are the two formulas we're going to need to know at the end of this lesson in order to do some of the problems that I have for you there. Okay, so where does this come from, and how are we going to use it? So first thing, where does it come from? It comes from this. So first off, we know that going around a whole circle is 360 degrees. We also know that the circumference of a circle is 2 pi r. That's the circumference of a circle. And by the way, if you didn't know that, we could all just Google that. Like, hey, what's the circumference of a circle formula? It's 2 pi r, where r is the radius, right? So the radius of the circle does impact the perimeter of the circle, the length of that outer part, right? So that's why it's important, 2 pi r. Cool. Now what we do is, like, we try to solve for r is what I'm going to do. So in order to solve for r, I'm going to divide both sides by 2 pi. And we could do that because, again, 2 times pi, that's a number. Pi is 3.14. So 2 times pi is like 6 point something. So we can divide both sides by 2 pi. When I do that on this side, the 2 pi's will cancel out. And right here, what I'm going to do is I'm going to do 360 divided by 2 in my next step. Notice again, the 2 pi's went away. R is left by itself. And now we have 360 divided by 2. That was 180. The pi is still down here. I didn't do anything with that pi. That's why it's still in that denominator position. So this represents, basically the r right here represents like 1 radian. That's what it is. Like the radius, 1 radian. So 1 radian is equivalent to 180 degrees divided by pi. That is right here. And basically, what we use that is to convert radians to degrees. And if we flip that, if we flip the same truth right here, we'll be able to convert from degrees to radians and vice versa. So this right here is where these two formulas come about. It's because 1 radian is equivalent to this. And when we multiply the 1 radian with a radian degree, it's going to give us an equivalent degree answer. So again, this is where these formulas come from, what I just did. And they're right here. So now it's how to use them is the next part. Okay, so we're going to be using these. Here's example 1. Convert 60 degrees into radians. Now, if I want to go from degrees into radians, I want to make sure radians is in the numerator position, so this is the formula I'm going to be using. So the first one, not the second one. Notice that in addition, this is the correct formula to use because degrees up here cancels with the degrees down here. So the degrees should cancel out and I should be left over with just radians. So it makes sense in that way. Okay, the next thing I'm going to do is I'm going to try to cancel out some stuff. I could also take out that 0 right there. You could do that when it's like multiplied by 10. You could simplify like that. See? That's why I got 6 over 18. I canceled out the zeros because that's like multiplying by 10. And then we had 6 times pi. That's 6 pi. And then down here we're left over with 18. Now we could go ahead and reduce this fraction. I know that 6 times 3 is 18. And we have a 6. We could basically cancel out 6's there. And then that gives me pi over 3 radians as my final and simplified answer. So basically, 60 degrees is equivalent to pi over 3 radians. And if you were to look at what I mentioned about unit circle, you would see that matched up. So that's how you convert an example of degrees into a radian measure using, again, the formula. In example 2, let's talk about how to convert a radian measure into degrees. So going differently. Now for this one, notice that I'm using the reciprocal of the previous formula in example 1. So example 1, I did pi radians over 180. Now this one, I want the radians down in the denominator position because the radians cancels here. I want the radians to cancel out and I want to have degrees on top because what I want is degrees. It wants us to convert to degrees. So that's how you know when to use which, right? The 180 over pi versus pi over 180, when to use it, depends on what you want to get rid of and what they want. So degrees, that means degrees needs to go on top. So right here, radians will cancel out. Another thing that cancels out, which is nice here, is the pi. So pi will also go away. So I just have 180 degrees divided by 6. And then you can use a calculator here, or 180 divided by 6 is actually a nice number. If you use a calculator, it's 30 degrees. So we've just shown right now that pi over 6 radians is equivalent to 30 degrees. And again, remember, radians is like the distance of the perimeter or arc length of the circle. So the arc length of 30 degrees, pi over 6 radians. Alright, so there we go. Do make sure that after watching these videos, this video, you complete the problems I have for you. I'll put about 4. And then we're going to jump back in to talk about this in our live lesson. Good luck, everybody.